Hello again, my darlings. We are now looking at 5.2. We're still looking at discrete random variables, but now we're going to look at how to find the mean, expected value, and standard deviation of a discrete random variable. So we're going to start with the mean, and it's still mu. Mu is still the variable that represents the mean. And remember, this is the letter sigma. It means sum, add everything up. And so this is just x times the probability of x. So for each of the different possible x values, we're going to do x1 times its probability plus x2 times its probability plus all the way down to the last x times its probability. For standard deviation, we have to first find variance. And so we're going to be adding, but notice it's x squared. So x squared times its probability. And then at the very end, we're going to subtract the mean squared. So we have the first x squared times its probability, plus the second x squared times its probability, plus dot, 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 all the way down to the last x squared times its probability, and then finally minus the mean squared. And standard deviation, just like before, once you have variance, just take the square root of the variance and you get your standard deviation. So example 1, our discrete random variable x is the number of courses for which a randomly selected student at a certain university is registered. So students could be registered for anywhere from 1 to 7 courses, not 0, because if 0, then they're not considered a student at that time. So mean, we just multiply and add. That's all we do. Multiply, 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 and add it all together. So 1 times 0.02 plus 2 times 0.03 plus 3 all the way down to plus 7 times 0.05. So we get 4.66 classes. So on average, a student takes between 4 to 5 classes. The standard deviation, well, now that's this other one. That's where we have to do the x squared times its probability. So 1 squared times 0.02. Plus 2 squared times 0.03 plus all the way down to plus 7 squared times 0.05. And then you have to minus the mean squared. So minus 4.66 squared. And all that equals 1.4444, but that's the variance. You still have to take its square root to get the standard deviation. So what the standard deviation tells us is, yes, the mean is 4.66, but if we add and subtract this, so 4.66 minus 1.2 would take us down to 3.4, so approximately 3 classes. If we take 4.66 and add the 1.2, it takes us up to 5.8 or approximately 6 classes. So it pretty much tells us that like 68% of the student population is going to take somewhere between 3 and 6 classes. Okay. All right, so another concept is called expected value. It's just what you expect to happen if you were to just continue doing this over time. So the expected value actually is the same as the mean. So this thing right here. So the average number of classes taken is 4.66, or if you over time were to go and ask one person and another person and another person and another person and another person, if you took all the people you asked and took an average, you'd get an average of 4.66. So a way this is really used a lot is playing games. If you were to play a game over and over and over and over again, so if a expected value was, say, $1, in the long run, you would expect to average $1 per game. Some games you might lose, some games you might win more than $1, but if you played over a long period of time, you would expect to average $1 per game. So example 2, a person draws a card from a deck of 52 cards. If they draw a face card, they win $5. If they draw an ace, they win $10. If they draw any other card, $0. Bum, bum, bum. So how much should this game cost to be fair? So we need to know, what does it mean to be fair? Well, a fair game means in the long run, you don't win, but you don't lose. You break even, which obviously most people aren't going to do that. You go to Vegas, you go places, you pay to play the game, and you pay more because they're going to win. If they don't win on the regular basis, they would shut down. So unfortunately, in real life, the games are not fair. So first thing we have to do is create our probability distribution. So X represents the amount of money that you win each time. So there were 3 choices. You could win nothing, you could win $5, or you could win $10. So I'm going to start with the 10 because that was by getting an ace. Well, there's 4 aces in the deck of cards, so the probability of winning $10 is 4 out of 52. A face card gave you $5. Well, there's 12 face cards in a deck, so the probability of winning $5 is 12 out of 52. And there are 36 other cards in the deck, so the probability of winning no money is 36 out of 52. So we use this probability distribution to find the expected value. So remember, multiply, 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 and add it all up. So 0 times 36 out of 52, plus 5 times 12 out of 52, plus 10 times 4 out of 52 is $1.92. So in the long run, you would average winning $1.92 a game. So to be fair, the person running the game should charge you $1.92. Because that means in the long run, you don't win, you don't lose, everybody breaks even. That's it for today, folks. Good luck on your homework. Have a wonderful weekend. Love you all. Have fun. Be safe. And I will see you on Monday.